Hi friends, welcome once again to a new and interesting session from Kash tutorials. So hope you remember the last time we discussed about a tree diagram in which I shared with you about a combination of shirts and trousers, and we saw that if I was having two trousers and I was having three shirts. Okay, if I wore T1 and T2 trouser and I was having the shirts as S1, S2 and S3, probable combination which I could have was either I could have a T1 with S1, a T1 with S2 and a T1 with S3, or on the other terms I could have T2 with S1, T2 with S2 and T2 with S3. So in combination, total number of combinations which came out were, so if I am having two trousers and three shirts, the combination which was coming out was the totaling which came up to 6. Just to put this in perspective more clearly, if I am having m objects and I am having n objects and I want to see how many ways I can arrange both of these. I want to see in how many ways I can arrange both of these. So it would be m objects I could arrange in m number of ways and n objects I can arrange in n number of ways. So the total number of possibilities which was coming was m into n ways in which I can arrange these. So this was nothing but the fundamentals of the counting principle. Building upon this, today we will discuss something very interesting. So just remember this: m into n ways of arranging m objects and n objects put together. Okay, now I would share with you one more example today. 3 guests are visiting my house and I have got these 3 chairs lined up for them. These 3 names are A, B and C guests are there, and I am having 1, 2 and 3 chairs for them. Firstly, I am going to discuss about possible number of arrangements for seat 1. So seat 1. So in seat 1, if I decide, I can have my guest named A coming in seat 1, and for the moment I leave seat 2 and seat 3 unaddressed, or I can have this guest B, so I can seat guest B on seat 1 and leave these 2 seats for the moment, because I'm arranging only possibilities for seat 1. Third possibility, I can make the guest C sit on number 1 seat and I can have these 2 left aside. Now once the seat 1 is filled, I am going to look into filling this seat, which is seat number 2. So seat number 2, when seat number 1 is already filled. So let's see what are the various options in this. I am already having this A named guest, so you can see in this second place, either I can make the B named guest sit or the C named guest sit on this. Now let us see into this second part, where I have already B sitting on one number, The second and third seats are empty. Have the option of putting A over here, and by simple logical reasoning you can understand what can be the third person who can sit over here, but for the moment let us consider we don't know. On this second seat I can place, so B is already sitting on this first chair, second chair we have C, and third chair I have again empty. Okay, so I have this third option left. Let's see what we can place over here. So either we can place guest B on this chair, or we can place guest A on this chair. Seating, third option. So when I've already seated the first guest, I have seated the second guest, I'm seating the third guest. I would be talking about the third seat. So in the third seat, A and B has already taken the seat, so only one which is left over here is, yes, correct. So this comes as the first option over here. The second is also easy to understand. A and C have already taken the seat, only B is left, so B would come and take the seat. So B has already taken this seat, A has now taken this seat, third is C who can take this seat. Similarly, B has taken this seat, C has taken this seat, so only A can take the seat. Now let's see about this option over here. So C has already taken this seat. In the first one I have B, so A can sit over here, or I can have C, A in the second. Over here I have the A, over here I have the B, so this second one which is left is B. I had seat 1 and I had got these 3 persons whom I wanted that they should occupy the seat. So in that case, how many number of options I was having? Yeah, so I was having 1, 2 and 3. So in seat, so to fill up this first seat I had an option of 3 people could have taken this seat, that is A, B or C. So once any of these have taken the seats, C has, when seat 1 is already taken care of, seat 2, how many options are left? I am having how many options? I am having one option as this and the other option as this. So on one seat, once the seat 1 is filled, I have got these 2 options B and C who are taking the chair. Similarly, when the first seat is filled up over here, I have got 2 options. Over here also the first seat is filled, I have got only 2 options who can take the seats, that is A and B. Once the first seat is filled, I have got only 2 people who can take the second seat. Once these 2 seats are filled, I have got only 1 person who can sit in the third chair. Similarly, you can see over here I have got only 1 person who can take the chair. If you remember what I said earlier, if I have got n objects, the number of ways in which I can arrange is m in n ways. First chair they all could have filled in 3 ways, second was in 2 ways, and last was in the 1 way. So 3 into 2 into 1, that is 6 number of ways. 1, 2, 3, 4, 5, 6. These are the 6 ways in which they can seat. Let's see now how we can seat 6 people in 6 chairs. So we are having different people over here. We are having A, B, C, D, E and F as people over here, and chairs which we are having over here also 6. So these are those chairs. 1, 2, 3, 4, 5 and 6 chair. So let us understand how we can do this. So all these 6 people have got equal opportunities of sitting in the first chair. So in the first chair, how many people can sit? 1, 2, 3, 4, 5 and 6 people. So first seat can be filled in equally in 6 ways. Once one of these person has sat over here, the number of people who are left behind are 5, and so the second seat can be occupied by 5 people. Once the first and the second chair are filled, the third chair can be filled by only 4 people. The fourth chair can be filled by 3 people. Fifth can be filled by 2 people, and the sixth chair can be filled by only 1 person. This comes as 6 into 5 into 4 into 3 into 2 into 1, which can be also written as 6 factorial. So if I have got 6 people and I want them to get seated in 6 chairs, I have got these 6 factorial scenarios to make them sit. Now suppose we want to seat these 6 people and we don't have 6 chairs, we have only 3 chairs. So once again the people would be the same people we are taking. What we are changing is the chairs. Now we are having only 3. We are having only 3 chairs. So let's see how we can make them sit. So in the first chair we can have all these 6 people who can sit. So the 6 ways in which this first chair can be filled. So once one of the person is already sat on this, we have again left behind 5 people who can sit on the second chair, and only 4 people are left to occupy the third chair. What we get over here is 6 into 5 into 4. Okay, so these are the ways in which we can seat 6 people in 3 chairs in these many ways. So if I want to relate somehow this outcome I want to relate with this outcome. Why? Because this is something which I would like to relate over here with this. So in fact, if I want to get this thing out of this thing, what is the easiest way is, this is what I can rewrite it as over here. I can rewrite it as 6 into 5 into 4 into 3 into 2 into 1, and I can divide this by 3 into 2 into 1, and then I can easily strike off these all, and what I would get is 6 into 5 into 4. So this thing can be again rewritten as, 6 factorial over 3 factorial. Now you would be thinking, where did I get this 3 from? So let us understand this in a different way. So what we were trying to do over here was, we were trying to put 6 people and we were having only 3 chairs. So we went up till these 3 places and we skipped these 3 places. So this over here can be deducted from the number of people minus the number of chairs which were available. Okay, so over here we are having 6 people and we subtracted 3 chairs and we got 3 as the answer. So why I have done this? I want you to intuitively understand this instead of mugging up anything. So we can understand this as a generalized concept, as we are having n number of people and we want to make them sit in r number of available options. This option, this P, is known as permutation. Also it says that we have got n number of things and we want to see how they can be arranged in r number of places. Okay, so this can be written as factorial n over factorial n minus r. You can relate over here. N were the number of people, so where n we were having as 6, so we wrote 6 factorial over here. We were having 6 people over here and we were having 3 numbers of chairs over here, which was 6 minus 3 factorial, and so the answer which we got was 6 factorial over 3 factorial, and this answer is same as this answer. So this is the generalized formula for permutations, which says factorial n over n minus r factorial. I could have easily gone ahead, asked you to mug up this concept and put it in your other problems, but this would have been difficult in the long run. So in the long run you will get questions which would ask you that you want to make people sit and one person should sit in a single place, or 2 people want to sit adjacent to each other. In those all cases you would find it very difficult over here. Please do comment on my video and subscribe to Kash tutorials. I would be looking forward to hear more from your side. Please do reach me on my subscription channel. Thank you and bye for now.